Welcome back. My name is Corey. You're my rubber ducks, and this is the episodes or the series, whatever, where we are creating a programming language from scratch. The programming language is called Tang, and slowly but surely we are implementing different parts of the languages and just raw C++, with a few tools like Bison Flex, Google Test, ICU coming soon, and um, Vim as our editor. So it's just 100% live coding. I often say nothing up my sleeves. It's just all right here in front of you. And well, let's just jump in for starters here. What is today going to be about? What did I put on the thing? Printing output. Yes, we wanted to. If we say print something, it should print something. Well, okay, so we're going to. There we go. Wasn't responding. Um, had to hit Control Q. If I say the log where we were last, the very last commit is episode 30, and normally I will say, and look, get status. I haven't made any changes, but I have made changes on this one. And the reason is because I'll just show you in a diff. I have in the include tang.hpp just because I needed to put it somewhere and I didn't want to put it in the main readme. A to-do list. This is not necessarily to do in this order, but it's things that need to be done. And I thought we were probably pretty close. Where this is episode, was it 31? And well, there's this list has just the new parts. There's over 50 things, and maybe it's not going to take an episode per thing, but there's some lines in here that I'm thinking that's probably going to take more than one episode. And so this is just kind of getting all my thoughts down on paper. Some of the highlights we'll see here are the getting started with ICU, and because the big thing about that is working with Unicode, and because we want our programming language to use Unicode first and foremost. There's a few other things. There's a few refactoring things. I want to revisit how we're doing our location tracking for the bytecode, so that if you say print something out, you know where in the script that it had executed, where that traces back to. Our array here. That is, we'll be adding arrays, and that means we need to add the square bracket operator, arranged for, slicing, a use syntax for importing libraries and things like that, and it could be import, it could be from this, whatever. There's a lot of different ways we can do it. I'm leaning towards just using use. Objects, not user-defined object classes, but think more like hash maps of sorts, and the ability to be able to specify them programmatically. Somewhere in here, I've overlooked it. I think I had functions, or did I just miss it? No, functions. Oh, it was right there. Well, functions on objects. That's a bound function. A function that needs to pass the this variable, this value, along with it, the pointer to the object that it's referring to. I thought it was up here. Template scanning. The main point of what we're creating this program for right now, we're doing it just as if everything is a script. But no, it's like, no, it needs to be able to have a template that it can then go into the scripting mode when it needs to. So we'll be doing that. The library extension, a way of other languages, not languages, being able to write, other developers be able to extend this library. Yeah, that's what I'm trying to say. Oh yeah, providing a proper math library that has the parts that we're missing. Probably a date and time library. An execution count timeout. This is the ability to be able to say, I don't want you to be able to run in an infinite loop. We'll look at that. A standalone interpreter program. That way you could run Tang and then give it a file that is either a script or a template, and it just execute it. And then the optimizations that we've kind of been putting back. We haven't looked at. There's a lot of stuff there, and that's a lot of work, and some of it's a lot more work than others. But that's all right. What are we doing today? We're going to implement a print function. And I'm going to have to turn on this fan here. I'm sorry you will hear it start running in the background. But it's hot up here and I need to get the air moving. You'd say, Corey, why don't you just use a windscreen on your mic? I do. Oh wait, that's just out of... There we go. It's just out of... I do use a windscreen, but oh well. Okay, now that I moved that, I'd have to put it back. Give me a second. There's no graceful way of doing this. There we go. Okay, so this to-do list, I'm just including it, and git commit dash am for direction. I don't want to call it a roadmap, but oh well. But yeah, it's a little over 50 lines, so that's all right. Now, we want to get started with a print functionality, and I don't think we need to add, I'm saying this, we need to add an opcode. Well, yes, an opcode, but an AST node for printing. And let's copy the unary. So first, let's edit our make file. AST. Well, that's not what I'm intended to happen. Okay. AST node, there's our for if identifier, integer. It should pretty much go right here. Yes, right before string. And we'll say print AST node string this one. I need to move that just a hair so I can see what I'm typing. Okay, so I've got this print thing, and we need to copy the include for AST node, and like I said, I'm going to steal the unary, and it's going to be include AST node print, and then copy the source for AST node unary to be the source for AST node print. Now we need to edit the include for AST node print, the source for AST node print. And what else? Well, we know we're going to need you say, Corey, you just kind of stopped there. I know, I'm thinking. The source program dash, is that right? Yes, dump bytecode. The source program dash execute, and also the include for the opcode, and our flex, bison, and test. Well, that might be everything. Okay, so we need to now globally change, because this is we say it's the unary, but it's we're in the ASC node print, right? So %s print all right, and we can go to the next one, redo those same okay, we're back to our first one, and now we're now we're just looking for what changes do we need to say. So this is an ASC node that represents a print operation, and there's going to be several different operators. And what are they going to look like? Let's just have a default, and that'd be the only one for right now. Print. Yes. Now what's the default print? We don't know yet. Well, what I can tell you is, remember, this is ultimately a templating language, and what we're trying to do is we're trying to be able to print out something. And by templating language, I mean ultimately intended to be used for HTML documents, for example. And so if I say a user name is whatever, they supplied me a username, and I want to print that out, it should be escaped so that it's safe to print that out, so that there is no HTML injection attack possible. And ultimately I want these our strings and everything to be able to carry with it a property that says, hey, I'm safe, I've already been sanitized, or I'm not, I need to be sanitized. And this print should be able to just look at the situation of the string itself and make the correct decision what needs to happen. And that's as it passes through the stack and is passed around, and that's what the goal is. So let's continue. So our operator is the ASC node print operator to apply to the operand that it's not really the type, it is the I don't think I want to call it operator, because it made sense with the unary and oh, I forgot to add ternary expressions to the list. I'll get that added. The operator. And let's just call it type. The type of print. Requested. There we go. So this is the, instead of op, can I call it type? Or is it gonna, I don't think it's gonna complain. To apply to the typerand. Sure. This should be expression to be printed. Location is fine. Okay, so this expression, there we go. Dump should be file, compile identifiers. That's fine. This is the being requested. There we go. Typerand. Oh my. Okay. I think that that's good. So let's change this. What do we need? No, we need to do now. We need to do operator needs to become type. Op needs to become type and typeer and needs to become what did I call it? Expression. Oh my. Okay, now let's see what makes sense and what doesn't. I don't need bit anymore, do I? So our print will have the type, the expression, that's fine, and it feeds in type and expression. Fine. We don't need the Yes, we do. Yeah, it's just being called default. Print default. That works. That's right. And then the compile. So here we will say default print, and just a print statement. And I think that will be good, even though we haven't defined what that is yet, but we'll be doing that shortly. In fact, let's go ahead and write that, the opcode print. And at this moment, we should be able to start at least doing our there we go. Type code. Opcode. There we go. Yeah, print doesn't exist. I know. We're about to add it. And let's do that one first. So where are we going to put this thing? Let's put it at the end. Why not? And this will be print. And this is going to be, we're going to pop a value, print val. What should it leave on the stack? Push result error or null. So if there's an error in the print, we'll push that. Otherwise, just push a null. So the print is responsible for pushing something. That's the point of that. Okay. I can live with that. It's going to go through some stuff. That's fine. This is the dump bytecode. So we're going all the way down to the end. So print, and yeah. Now it gets interesting. What do? We're going to make sure that there's one thing on the stack, and now we're going to pull it off, and it's going to be expression, and remove it. And now, remember, we've got program. So let's think about this. What should the result of yeah. So back to what I just stopped saying while I was thinking. if expression is the value we want to print, how do we turn that into something that is printable? And the answer, I'm just going to leave that there for the moment. If we open the include for because these are garbage collected values, right? So garbage collected. Okay, we're looking here. Is there anything that that we have here that will convert it to a string? Copy, move, copy assignment, move assignment destructor. That. We do have friendly output in that way. Is that what I want? Say, what do you mean, Corey? Well, I'm thinking that we need to have a no, I don't need to do this. I don't need to go through the garbage collected. Let's go directly to the computed expression. We've got our bool is equals we never added a typecast to a string, did we? But that's basically what I'm asking it to do. Give me it typecast as a string, and then I'll use that. That's the goal. That's what we want. Okay, so just like we have all of these, perform typecast to string. We've got a dunder string now. We need to add that to the source computed expression.cpp, and we need to add the dunder string. Oh, there we go. And if it's a null, what should it do? Don't know how to convert this to a string. And that's what I'm thinking. Is that what, if it's a null, it shouldn't print out a null, it should return an error. Ooh, we're basically defining how the program works now. But that, okay, so that's what I'm thinking. All right. Now, what we need to do is, just to start off, we need to add to the includes for computed expression string just a pass through, right? And now edit the source not AST node, but computed expression string okay, and just return, make a computed expression string, and then this val. Is that good enough? Say, Corey, you're making a copy. Yeah, we don't have a better way yet. Oh, and it's called boodle. Well, I'm calling it. There we go. String. All right. So that's gonna pass through, in theory. Let's go. Which one were we on? Buffer 4, the execute. Okay, so the result is going to be expression string if yes, I know I'm stopping again. The string is private. But if I call the dump, I get the string. Okay. There we go. So if type ID of result is equal to the type ID of computed expression string, then program.out plus equals result dump push back just a regular computed expression of no type, which is a null. Else pushback result. Okay, so what are we doing? we're saying there we go. So try to convert the expression to a string. Okay, I think I like that better. So if it doesn't equal an error, then just get the dump value, which everything has a dump value, and push back an empty expression, which is a null. Otherwise, push back the result. And that's what's going to happen with the opcode print. See if it likes that or doesn't. Program was not declared. Oh, because we're in the middle of the program. That's why. It's this. Hit those keys out of order. Yes. Okay, so nothing's failed yet. Let's write a test, and I've got that for number 7 or number 8, buffer 8. There we go. Oh boy. So print, and then this is going to be the default print. And all that we're going to do is we're going to say print hello world. Oh, close semicolon. Okay. Should have made that number 2. There we go. Why? I want an empty one for the first one. And p1.execute, and now I should be able to say .out, and it should be an empty string. Likewise, this one, the output should be hello world. And now let's just go with that. It's of course not going to. Oh, Okay. It at least recognized what I was trying to do here. So what is this? So the program, when we say Tang base compile script, right? That is, there we go. It is the program object has a dot out and it's empty. And in fact, we should expect eq p1 dot out to be an empty before we start out. And I'm going to double that here with p2 because the point is then afterwards it's hello world, and it's still hello world. Okay. Yeah. Semicolons. Semicolon. There we go. And that's just a side note. Want to make sure that it's working how I expect. So 632 and 633 are failing. So 632 and 633 are failing. Notice 631 passed because it's just saying, hey, verify that the default is an empty string. It is. And these two, because nothing happened. But the reason that nothing happened was more just happenstance of it not knowing what to do, so it didn't do a thing. And so yeah, we're about to fix that. We're about to tell Bison and Flex what these things are. So let's do that. We're going to go to, which one is Bison? That is 6. Or Flex, I meant. Number 6. There we go. And we're looking down at our kind of keywords. Inflict bool, true, false. And we're going to add one. Now, the way we're writing it, print looks like a function. But it's not. It's actually a keyword of the language. We haven't written how to do functions yet. And this will actually execute faster than trying to call a function. So that's why I'm doing it this way anyway. But if I see a print, then I need to return a Tang print. And what do I need to give it? Oh, just the location. Location. Okay. It's going to complain that it doesn't know what that is. That's fine. We're about to add what the print is. And that's going to be here. These are the things that we, the tokens. For as null int float boolean. Let's put it there. Don't know what happened there. I hit something and it was a shortcut that I don't know what it is yet. So print. And we need to add this to our AST nodes. AST node print. And now we've got this idea we could have a code block. So of our close statements, that's what we're looking for. Or is it an expression? It looks like a function. I think it should be almost treated like a function. Because it returns a value. Yes. So we're going to put it under the expressions. There's that. And what is this going to look like? It's going to be a print, open parentheses, an expression, close parentheses. Yeah. AST node print. And what does this require? This requires our node print, and this is the type, and we're going to say a default and $1, 2, 3, the third one, and its location, let's just say at 1. Sure. That should be correct. Let's see what we broke now. It claims to be passing everything, and I don't believe it. So let's break something. We broke it. Okay, let's add a few more tests then, shall we? If we... That should have been that. Just for the moment, because I don't need that anymore. And if I replace that with a 3, this is a 3. And now, if I say print... That is not what I meant to do. There we go. And a 3. It should give me a 3. Okay, give me nothing. That's fine. Well, it's not fine. I wanted it to work, but let's see what we're getting. So p3 dot dump bytecode. Integer print. Seems reasonable. Oh, we didn't tell the integers how to cast to a string. That's why. Okay. Whoops. On the wrong window. There we go. So we need to edit the... Well, forget that for the moment. First, here, I'm going to go ahead and do the 4 and 4, and we'll do this as a 3 point. I think it's going to be to give us zeros when we do it with a float as a default. And by the way, I have as one of the bullet points of the to-dos to format numbers as a string, and right now this is just going to be kind of like the default. What else? True. And do I want this to actually say the word true? Or should that be nothing? I don't think a Boolean should explicitly print anything. And so I think we should do that with a false as well as with a null. They should all print out nothing. So now I've got integer, float, Boolean, null, and of course string. I think that's all of them. So all of those, well, they're going to pass because I'm just verifying that they're doing what they should do. But the integer and the float are not. So we need to add them for integer and float. So we're going to edit the include for computed expression float. Sure, we'll do the float first. And there we go. Boolean and string. And now we need to edit the source for computed expression float. And just add it to the bottom. String, and it is going to be a I think it's toString, isn't it? Is that what I do for the dump? Oh, let me just call that. There we go. And what does it not like? Oh, it doesn't know what a computed expression string is. Well, that's your own fault. Ah, so it does add zeros. It just adds more than I was expecting. But that's okay. We can fix that in just a moment. I want to go ahead and do the include for computed expression integer. It's fine. And now we just need to do its string cast. And edit for the source of computed expression integer. We know that we're going to need to include that. Jump down to the bottom. String, string, this, dump. Just get through that really quickly. The only one that's wrong now is that 5. Nope. 4. Okay, I don't know where it is. Where's the test? Set 8. Buffer 8 is the number of zeros that gets printed, and it should be, looks like 6 zeros. And like I said, we could provide a library function or a function. No, it should probably be a library function, which will be something later that will be able to format the output however you want it, or be able to format it. But where does this put us for the moment? And the answer is we now have. Are there any others that we need to do? So we've got an empty string, a string with words, integer, float, boolean, null. You know what? I want. Well, there's a couple other things here. Just say hi. There we go. Print A, and that should give us a hi. It does. Good. Now, if I do 3 plus, whoops, that should have been a 3, plus 5, it should give us an 8. That should still pass. So expressions, it works for expressions. And then the last, I want it to be, if I do a 3 plus null, it won't. Oh, because it's 9. 10, 10. Yeah, it gave me, the out is nothing, but if I do it as there, that's what I was looking for. I want it to be an error. And how do I compile this error? How did I do this before? Oh, yeah, I just, error. Cannot divide by 0. I'm expecting it to be an error with how to cast this value to a string. Sure. Okay, no, this isn't right. Although I will write this just for the moment. Just to get it to pass, and then we're going to break it again. What's the problem? An error should have passed through. So the error shouldn't have been on the 3 plus null. It should have been on the fact that it doesn't know how to add those two. So let's fix that. edit, and that's going to be in the include for what is that? That's the computed expression error. There we go. And you see it has definitions for everything except casting to a string. And now we need to do the source for computed expression error. String, and it should be that. Okay, good. So now, number 8, instead of don't know how to all of that, it should be don't know how to add these values. There we go. And that's just percolating the I don't know if I keep using that word, but I think of it bubbling up the error passing through. And I think we covered all of our bases. Yeah. So now let's kind of look over everything. We know we need to add the include for the AST node print and the source AST node print. And now the diff on everything else. That was Bison. Adding our string casts. Yes. And I want to add one more test, okay? Not get. Vim. And the test I want to add is this one right here. And this is 11, and the reason is I want to print. No, I don't want to do that. I want to there we go. Just to see it fail. Move one. Should fail. Yes. And probably need. Oh, it's like why is it 10? Because I is equal to I plus 1 was the last thing that it executed, and so that was left on the stack. Ooh, does that mean we didn't clean it up? There may be another bug here. P11 dot dump bytecode. Okay. What are we doing? So null val, that is for the I. Integer 0, poke that in there. And now we're going to pop it. That's fine. Peak 0, that's looking for the that's loading I. Integer 10 less than. Jump if false to 29, which is passed. That's fine. The string that, calling print on it, pop the result. Peak 0, that's I, is I plus 1, poke that in there, and then pop the result. And then jump to 6. That seems correct. Okay, that does seem correct. I'm going to keep that in the back of my mind. I'll be thinking about that. But why didn't this work? Because it should be out. Yep, and I need to add back a dash. There we go. So multiple print statements. That was the goal. Print being called multiple times will in fact output multiple. It'll add together. Okay. Now I think we're good to go. So, Corey, do we really have to think about all this stuff? Yes, yes, yes. If you don't write it, it doesn't exist. If you don't test it, you don't know whether or not it's working correctly. So, as of this point, what do we need? We know we're good here. Git commit -am add default print and string casts. Sure. Make the docs, make the computer sound like it's about to take off. I think you can hear it. I think it comes across now. But there we go in our files now. Stuff should be showing up. The AST node print. There we go. Same way with the class AST node print. Yeah, it's there, and just want to see. Yep, a lot of stuff there. We've got 2 cycles. Those are always headaches, but oh well. Okay, having said that, we need to push it, and I don't remember what episode we're on. Episode 31. Now, guess what I forgot to do? I forgot to take it out of the to-do list. But if we look at the include tab tang.hpp. There we go. We'll remove that next time. And then the question is should we write functions? That would be a handy thing to have. Should we continue and break? That's going to be how do you exit out early out of a for loop or a while loop. And why did I put it off? Because it actually has a behavior that is similar to the return behavior of a in a function. And so it's like, well, we could, I was putting it off intentionally. But then we've got this idea of a string literal and a stack. You see, if you think about the code we just wrote, the loop, every time it goes to the loop, it recreates that string. But it's a string literal. Why not just create it once at the very beginning and put it on the stack just like a variable, and then peek it out? Because then it's just using a garbage collected value, which is very fast to use. So we could do that. That's a thought. And that's why I wrote it down. And then going into the ICU stuff. Oh boy, so much stuff. And I forgot to write down the ternary. So you know what? Here's what I'm going to do. I'm going to remove that, and it will be the first thing that we commit next time. And somewhere in here, I would almost rather do it sooner rather than later. Let's do the ternary operator. I like the ternary. I think it's very elegant. So anyway, okay. So that's there, and yeah, it didn't cause any recompiles to happen. Well, you know what? We're here at the end, and again, another great milestone. Oh wait, I was about to wrap up. The last thing we always do is just try to kind of see where our count is. It's creeping up there. 3849 of code and 1517 of comments. It's starting to a respectable size project. So, as always, I hope you've had fun. I enjoy this, so I hope that you've had fun as well. And as always, have a great day. Bye.